Well, welcome back to the Azure podcast. This is episode number 492, being recorded on the 19th of April, 2024. Teams with me, we have Evan and myself, and we're going to cover some of the news. We've been a little lax in covering some of the recent updates in Azure, and so we figured
just to be fair, there's a lot to keep up with.
It seems like there was this big flood, right? I don't know if it's like the preamble to what's the conference coming up? Is that Ignite or Build?
Is it Build or I think it's Build's coming up. I think I saw it on my calendar. Yeah.
So it could be just like everyone's teeing up all their stuff for that, or trying to get out some of the other updates before the big reveals are happening in Build, right? So there's obviously the big reveals. So and then I was trying to figure out if there's any themes in all these updates, and it really seems a little bit all over the place. There's some networking, there's some data center stuff. There's obviously OpenAI, our favorite topic, and one particular topic which I have not seen before, and I'm very happy to kind of just talk about that. Maybe you and I can have a chat about that, spend some time on that. So. Do you want to start, Evan, or should I kick off?
Sure. Yeah, I'll hit a couple of things, and two of these they're not new, but I think they're such interesting technologies. It's basically one of them went available in all regions, and the other one I think we added it. We added hardware encryption, but the two of them, one is Azure Virtual Network Encryption, and I'll have to confess, when I first this is ages and ages ago when, I first had a customer say, hey, I want to be able to encrypt all my traffic, within my VNet. My initial response was like, why? Isn't that what TLS or, at the time SSL, does for you? And as I've learned over the years, right, there's computational cost with that. Yeah. Not every protocol supports it and all that complexity. So now you have the ability to basically turn it on a VNet level, and then any communication between the virtual machines is encrypted, whether you encrypt it yourself or not. And then the other one, and I've always thought this was the coolest technology because it's really the intermixing of traditional shipping disks around and Azure, which is and we call it something different now. It's called Azure Data Box Disk. And so basically we ship you disks, and they're key to your account. There's a passcode or some sort of authentication that goes with it. You copy all your data, and then you drop them into this special shipping box, and then we connect them up into our data center where you can securely access them. And so this is really great if you have terabytes and terabytes and terabytes of data, or you have a transient connectivity scenario, right? Think about maybe an oil rig or a ship, right? Where you might have months and months worth of data, and you don't want to sit around waiting for the network connection to send that up. So you ship it periodically, and you do that kind of mechanism. So it's I just think it's a cool tech.
Also, I think if you do try to do it on the network, it's going to bog down your network.
For sure.
Some period of time, right? It could take I wouldn't say months, but hours or days, right? You'll be slammed on your network, and so that could be another issue.
Absolutely. Yeah. It's just a great way if you have a large amount of data that either periodically or maybe for an initial copy, right, you want to send it up there. It's just a really handy one. I remember a demo I saw years ago where like they had this was actually when it was actually a unit that we would ship, and they showed, the folks that built it throwing this box around and, showing how durable it was, but it's just kind of a neat technology from that sense.
Right. Yeah. So I also want to kind of go back to your VNet encryption story that you talked about. A lot of actually this came up with one of my customers in financial services recently, and they were working around it. Yeah, they really want this, and they were working around it by using IPsec. Between all of the VMs, right? That's kind of the, as you said, TLS, IPsec. Those are kind of the alternatives to doing that. But there's problems with routing, when it comes to IPsec, right? Because the connections are kind of have to be sticky or long-lived and things like that. And so, they did have some sort of concerns, like especially when it comes to reliability, or if, let's say, a data center goes down and you have to reroute things, it becomes a real tricky to kind of reroute all those IPsec connections, right? But now you're kind of getting the natural, Azure provided VNet connections that just happen to be encrypted. And, so that kind of opens up some of those possibilities. So yeah, they're excited to
Yeah.
move to that, and that's going to take a big load off, as you said, the compute for the
It's
VMs.
interesting because this technology, when you look at the way that we ended up implementing it, the computational cost still has to be borne somewhere. We're just moving it into the infrastructure, right, where it becomes a base capability of the service rather than
Yeah,
something the customer has to consume at their layer. So nothing's for free, at the end of the
yeah.
day, right? It has to hit somewhere. But yeah, it to your point, right? It's just so much easier. Just turn it on. You don't have to manage it. You don't have to do routing. You don't have to manage protocols. It just handles it under the covers.
And I don't know the actual implementation of this, obviously, but I would imagine they're using things like hardware encryptors, right? Like so that you're not doing this in software, right? Under the covers, they probably have things like what Key Vault has, right, where they can do the encryption in hardware very quickly without
It,
having to.
it,
Uh,
yeah, I actually, I'm not sure. I probably should know this, but I don't off the top of my head. But it wouldn't surprise me if this, comes with some of the offload capability, comes out of some of the offloading capabilities that we have, right, to the Azure Boost
the
stuff and whatnot.
ASICs, yeah, all
Yeah,
of the ASICs and the logic
yeah,
gates and whatnot,
yep,
right? They're all
yep,
pre-programmed to do this. Yeah.
yep, yep,
Cool.
absolutely.
All right, so kind of more on the dev side of things, stream analytics, as we know, is something that's a popular service. If you've got a stream of data, it could be log data, IoT data, whatever, and you're collecting it, you're doing some analysis on it. But typically, you want to take that data and you want to store it somewhere. And in the past, you've had to write code if you want to store it to, let's say, if you have a data lake or a Delta Lake in this case, where you want to store these vast amounts of data, right? Because you imagine it could be really a lot of data, which you can later on go and do some analysis on. And now with this new feature that's available, the Stream Analytics, without writing a single line of code, you can connect it to your Delta Lake to a Delta Lake table in Azure, and it'll automatically write all the data to it, right? So now you don't have to worry about losing any of your streams as you're getting it, as you configure the streams of data. Typically you have to write really optimized code to make sure that you were getting everything, staying up to date, not falling behind, things like that. Now you don't have to write anything. You just kind of set up this connector, the output connector that's available in Stream Analytics, and point to your Delta Lake table, and voila, you have all of your
Yeah, yeah,
all of your data. Kind of also in the same area as connectors, but this time for logic apps. Right, logic apps is, as we know, is a really nice way to build workflows, and people have been using it for long-running workflows, quick workflows, whatever. But it's a very extensible system. But with the advent of OpenAI, people want to be doing some sort of OpenAI sort of computation or step as part of the workflow, right? Maybe as part of the workflow, you're getting some information from the user, and you want to kind of do some sentiment analysis on it or whatever, right? We want to do some sort of AI on the data. And now you can do that because they have app connectors built into Logic Apps directly, right? So you just configure your Logic app connectors. It's one of the blocks and steps, as the way that Logic Apps works, it looks like kind of Visio flow diagram
yeah,
kind of
yep,
view. And so you
yep.
just throw in another block in there now, or another task in there to say, okay, this is an OpenAI task. You just do the configuration of it. And then you can send an input in, send a prompt in, whatnot, get something out, and then continue on, right? So nice, easy way to integrate, Azure OpenAI and specifically AI search, right? And I think the good thing of this is if you get some information and you want to do a semantic search on some data, you can do it also using this
Yeah.
technique. So it really opens up a lot of options for you there.
Yeah, I mean so this is really about, the building the capability to, if you have, you want to, run an OpenAI data set or an OpenAI analysis on top of some, some text or whatever, some of the classic ones, but now you can just do it in Logic Apps, right? There's no difference in terms of what you're doing with the OpenAI calls. You're just able to do it from the Logic Apps rather than having to write custom code to do it, right?
Yeah, exactly.
Okay.
With no code or low code,
Yeah.
that option, yeah, it's available to you.
Okay. Yeah, the OpenAI and the search, it's been interesting. I'm not sure about you, but like everywhere I turn around, it's being integrated into something, and I'm just seeing so many, like every summary that I read these days ends up being AI generated somewhere, at least for the first pass, and all that, like when you're doing FAQs and all that, like it's really kind of amazing how quickly it is showing up everywhere.
Indeed, yes. I think it's going. It's obviously as knowledge workers, we also use it a lot for our day-to-day work. Uh, you know, just working on my review right now, and it's like, okay,
Ooh,
when you
that's a
use
good point. I
OpenAI to
need
do
to
it.
do that. Yeah, I need to do
It,
that as
yeah,
well.
it's
Yeah.
it's that time
Okay.
of the year, so
Yeah, it is. May
it'll help
something
you.
is
It'll
when
help you.
mine's due, so I gotta get it. I gotta get working on it. uh,
Great. What do you got? What else?
excuse me. Um, the other two things that I wanted to, or I guess the other one that I wanted to call, and this is really a callback to, man, I used to do this ages and ages ago, but the HB 4 and HX series VMs, again, this is not a new SKU in and of itself, but we've enabled it for some new regions. And this is all about doing, FEA analysis and computational fluid dynamics analysis, some of these high performance computing stuff in the cloud. And I was looking at the numbers like, 1.4 terabytes of RAM and like these, I can't remember how many cores are in these things, but these things are just massive. I remember we used to have this was a company I worked at ages ago. We had some Sun Microsystems, server to do all this stuff. And like that was what it did, and now you just spin that stuff up in the cloud. It's just it's cool to see. But yeah, this got enabled in a couple of new regions as well.
Yeah, and kind of a nice segue into what I wanted to talk about, which is, our Microsoft Surface devices, the laptops and all. They're really come up with some nice, engineering designs with the hinges and all. It's
Yeah,
very
yeah.
reliable. And as it turns out that, they are also using Azure High Performance Compute to do all of the analysis, right? So
Doesn't surprise me in the least. Yeah.
yeah, yeah. So there's a nice write-up, and we'll put it in the show notes. But as it turns out, a lot of the CAD and designs, the simulations that they have to do, right? How rigid is this
Hmm.
hinge going to be? If I drop it on the floor 1,000 times, what's going to happen, right? They don't physically drop it on the floor. Obviously, they have the computer do it like thousands of times,
Yeah.
to figure out when the
Yep.
breaking point is, and by simulating some of those real-world physics that go into that. And so they're not really able to do it. What they've done is they've kind of they used to have their own server farm, so to speak, to do some of
Yeah.
this in the early days, but now they've moved everything into Azure HPC. So I know OpenAI gets a lot of attention these days, but I guess this is also a good call out that this traditional high performance
Yeah.
computing that
Still
has to be
exist.
done. This
Yeah.
yeah, and also in the yeah, go ahead.
I was gonna say, I wonder. Now I'm begging to know. I have to read the article closely and see if we talk about it. The dilemma with that kind of analysis is it's always how much detail do you have versus how long it takes to do the computations. And when I used to do this, the rule of thumb was overnight. If it was done in the morning, it didn't really matter how long it ran, as long as it was done when I come back in the morning. But now where you have sort of infinite compute. Like the level of detail that they're probably modeling this stuff to is probably pretty intense.
Yeah, and it's nice to see how they've created like almost like a digital twin out of all of the
Yeah,
hardware devices, right? And so
yeah,
by simulating that digital version, as you said, they make a small change. Oh, let's change the screw on this hinge, or run an overnight test to see how that impacts the reliability. Morning they come, okay, that's good. We'll deploy the new
yeah,
screw, right?
yep,
It could be
yep,
something as simple as that.
yep, yep, yep. Awesome. Yeah, it's cool.
So
There's some nice analysis out there when you look at the article.
yeah, I mean, where I was going earlier with the, with how people forget about HPC, again, with OpenAI drawing all the attention, people also forget this traditional machine learning, right?
Hmm.
Let's not forget about that, right? I think everybody
Has its
thinks like,
place.
yeah, OpenAI seems to be the panacea for everything, but it's not, right? I
No.
think it's clearly that there are some things that have to be rely on, traditional machine learning, where you have a specific data set that you want to do some sort of algorithm on. And so I do feel like people should take a step back a little bit. Customers should step back and say, yeah, I'm not going to just jump on OpenAI for everything, right? Let's look at
Hmm.
some of the traditional things to see what it can solve as well. But on a networking angle, you like networking, but I found this one interesting because it's related to app service networking, right? And app service typically, if you want to join to your own VNet, right, you would have to dedicate the subnet for that app service. That's traditionally been the case. You can only have one app service one app service plan, I should say, on a subnet. Okay, you can have multiple apps on that subnet, but you can only have one plan on each subnet. Now, as it turns out, that's quite an issue for customers that have a huge number of plans, right? Because now they have to carve up their whole network into dozens of subnets and whatnot, and to have that that requires a lot of IP address ranging. Even if you're using a private IP address, which is of course this is the case, you have your own private address. You still have to
It's a lot of
carve out.
overhead to manage it, right?
It's a lot of overhead. You're nickel and diming on the on the slash 24, 25 or whatever for every subnet to try and keep it down as much as possible, and it does become a hassle. So now the new version of app service, a new feature I should say in app service is the multi-plan subnet join. Okay, so you can have multiple app service plans join the same subnet. So they kind of remove that limitation that they had before. And that allows you now to much more flexibility. You can just kind of create maybe 1/24, 23 and put all your plans on there and then kind of monitor the usage as it goes along, So there are some kind of caveats still, I think, to that. Like you still have to make sure that you have enough of buffer to be able to, when they do the failover and everything, you need to make sure there's enough of space available in your IP address range. So you don't want to be too stingy on it, but it still gives you that
scale up and
flexibility.
scale down will
Scale up and
some
scale
of that
down
as well.
Yeah. It's going to it always takes one more than it needs, and so there's a little bit of those caveats to be to take into account. Hey,
this
who's
is where
there?
we've got our special guest today.
Hey.
Hey, Ilya, can you wave to the audience?
Ilya.
Yeah, there you
go. How you doing, buddy? He knows he's on.
Yeah, he does. Oh yeah, he knows when he shows on video. He's gonna say he's an old hat at it. I'll have to email his parents and his grandparents and tell them he was a guest. This will be the only time my family will watch our show. Is to see the grandkid. Just managing that stuff is tremendously difficult, right? And so you don't want to manage across the plans.
So I can imagine a lot of enterprise customers are going to be really excited about this update.
Yeah, for sure. So another networking one that I wanted to call out. This is actually really monumental in a lot of ways. So if you're familiar with ExpressRoute, and this has been our guidance for probably 10 or 15 years now. ExpressRoute is a single logical circuit made up of two physical circuits, but the two physical devices are in one peering location. And so the guidance for, like I said, 10 to 15 years has been, if you want redundancy of that, you actually have to have two circuits. And, it's not awful. The BGP is pretty decent about, managing two circuits, but it does require some planning and you have to provision this extra circuit. What we've launched in public preview now is what we're calling our Metro SKU, which now it actually physically splits the two devices between two distinct peering locations and two different providers. So now you sort of get the redundancy of multi-location, with really no change to your design or your architecture.
Right.
And we're rolling that out in such a way that the two peering locations are close enough that the latency delta between the two is really not significant. I don't remember the exact number. It's something like within 10 kilometers of each other or something. It's
supposed to be in the same metro or something like that.
Yeah,
right?
Is
that
exactly.
what it is? That's why they call it the metro is the name of the service.
Yeah, and that's why it's actually not available everywhere, at once, because there's only certain metros where there are multiple providers within the right distance of each other.
Right. I think the initial list of cities is pretty small. There's a few cities in Europe, I think, right?
I know there's some others in the U.S. that we're working to enable it for, but again, because of the requirements of you got to have the right, you got to have two different providers. They got to have no dependencies between each other, right? It's not going to show up everywhere overnight. But again, this is sort of the model going forward for people that, because again, you get the you get a significant increase in resiliency with really no change in your deployment or your architecture or anything else. That's like the best architecture resilience piece, right? Where you don't have to change anything and you get the benefit, right? It's sort of like Zonal. Zonal's awesome.
Right.
You check a box and now you're deployed zonally versus, deploying two VMs, you have to manage two VMs, right? So
Right. Cool. All right, so I got a couple more here, and one of them is Azure load testing, right? I mean, we've been talking about this a long time,
Hmm.
but believe it or not, it wasn't available in the U.S. Gulf region until
Oh,
today,
okay.
until now. So they just kind of generally made that available in, I think it's called Fairfax, right? That's the
Yeah.
name of the cloud, the
Yep.
U.S. Gulf
Yeah,
Virginia
it's the
cloud. So,
non-secret, cloud that's out there. It's just basically any government organization.
okay. And the secret cloud, we don't know. It's too secret. Nobody knows where it is or what the name is. I'm guessing, right?
We'll just call it the secret cloud. We'll
The
just call it
secret
the secret
cloud.
cloud. Yeah,
Oh,
yeah.
okay.
You have to know somebody to get in there. So that it's for that cloud.
All right. So the non-secret government cloud now has Azure load testing available in it. Um, Now, I did say there was one particular topic that I wanted to sort of cover right at the end, like, have a discussion about. And this is, believe it or not, IBM mainframes, right? I know we don't often
Wow.
talk about IBM mainframes in this podcast, right?
Yeah.
Because
Might be
they're
a first.
might be a first, exactly, right? And even mid-range computers, I think, at least I'm old enough to know what they are. These are traditionally known as, IBM 3270 or IBM CICS. I remember that IBM DB2, IBM MQ, and all that. So these are all IBM products that run on these big mainframe computers, which I mean, hats off to them, hats off to companies that are using them. They're still working and they still make them up. They make updates to them. They make them
Yeah.
faster, better.
Yep. Yep.
People always say, hey, why aren't they getting up the mainframe? Well, the thing is, the mainframes have been so reliable all these years, and they've had that reliability almost like the cloud does provide today. Multiple. Units and everything, automatic failover. So there's a
Hmm.
lot of stuff that the mainframe has provided, and so it does still power many companies out there, right?
Hmm.
But connecting that world to the cloud world has
It's
been
hard.
a real issue, right?
Yeah. Yeah.
Until now, right? So that's what changed now. So now we talked about logic apps earlier. Believe it or not, there's a logic app connector for IBM mainframes and
Nice.
mid-range computers, right? And so it can, like, if you have a workflow that does kind of tap into your mainframe for something, maybe you eventually send the transaction to the mainframe, or you're looking up something on the mainframe in IBM DB2, or calling a COBOL program via IBM CICS, or even just screen scraping using the IBM 3270 terminal emulator. You can now do all of that using this Logic App connector, right? So as part of your workflow, you simply configure the Logic App connector. It does use our, I think it's the host, what is our SN? We used to call it SNA server. I think now it's called Host
Oh,
Integration Server,
yeah.
HIS.
Yeah.
So
Yeah.
it does, it does use HIS to eventually talk to the mainframe. But so the Logic App can be configured to talk to HIS, which then talks to the mainframe, and you can integrate fairly easily all of the mainframe functionality into it's almost a way of modernizing your mainframe and
Yeah.
bringing it to the cloud with minimal, I would say minimal, but with not as much effort as you would imagine, right?
What's how do you do the connectivity in this world? Do you have to have, I guess you have to have hybrid connectivity on premises through, ExpressRoute or
That's
VPN or
right.
something like that.
Yeah, you do
Okay.
hybrid connectivity to your HIS box, and then the HIS box is, doing the actual protocol, IBM mainframe protocols and whatnot, as it traditionally has done. I think that's how it works.
Okay.
So
Okay.
yeah, so certainly, this is, I the mainframes. I guess what this does open it up is, I've built systems back in the 90s even, right, where we had to,
Careful, Sujit, you're
using,
showing your age.
yeah, no secret about that. um, so talking to the mainframe even in those days, I remember using Windows NT, writing
Yeah.
code in there, and then talking to what was called SNA server before
Mhm.
HIS, and then up to the mainframe, and then somehow we would make that connect to the internet, right? But it was a real hassle, right? There were like
Mhm.
multiple steps, to do, and lots of code, lots of custom code. Just now, it just makes it real easy, right? You imagine you're actually sitting in Visual Studio,
Yeah. Yeah.
connecting to the mainframe and just wiring it up in a few blocks of code or some, low code
Mhm.
way, And yeah, they've even got like design tools, in Visual Studio that show you what the emulator, the terminal looks like. You can say, I want this field from here, that field from there, whatever. I'll call this COBOL program, and these are the input parameters and the outputs. So, all of that now is kind of, just part of that flow, right? Using there's something called the 3270 design tool that's kind of built into Visual Studio that helps you do all of that.
That's just it's a little bit what's the word I want? Sort of like a cognitive dissonance to think about Visual Studio and these mainframe tools, because the two never really never really work together, and now you're just using this modern design environment, using modern connectivity, but you're still leveraging this oldie but goodie piece of hardware at that point. Yeah, that's cool.
Yep.
Cool. Awesome. Speaking of things that have been around for a long time, the other one that I wanted to highlight was Azure Site Recovery for shared disks, right? So if you do a traditional Windows HA cluster, a lot of times you can use a shared disk as your basically controls who's the primary instance at any one time. But site recovery has always had a limitation with that it wasn't aware of that shared disk, and so you couldn't back up that state of the entire cluster. You could do the VMs, or you could do the database that's in it, or whatever the case may be. But now we've released for a public preview the ability to do it on the shared disk. So now you can do that whole environment with one, sort of a few clicks. At that point, again, just making it easier to manage and run these things in the cloud and keep them up.
And interesting you say that, because there was one that I forgot also related to the backup of disks. And these are disks that have private endpoints, right? So if you have disks that have private endpoints enabled, backing them up has always been a challenge, because in order to restore that, they would have to restore that also in your private endpoint, right? So, it's a bit of a tricky thing to do. But now there's a public preview available where you can do backup and restore of virtual machines with the private endpoint enabled disks, right? So, and you can configure that, hey, when we do the restore, these are the network settings you want to use to restore the disk here, right? In this VNet, in this subnet,
because every VNet could theoretically have a different range, and so yeah, you're right. You have to be. It's a lot more complicated to figure it out. Yeah,
exactly. Yeah.
Good point.
Yep, and even the specific network access, the NSG, all that stuff, can be kind of set up as so that these disks are restored back seamlessly without you having to do jump through any hoops.
Yeah, great, awesome. The other thing, and I think we forgot this when we were talking about our OpenAI, but you recently redid our intro and exit using the OpenAI services, right?
That's a good point. Yeah, I forgot about that too. Yeah, we could talk about that. Yeah, so we've had I think it was Cynthia and Kendall's voice that
for a long time.
that have powered our intro and exit messages on the podcast. But we wanted to change some of the wording, right? I think they still refer to Twitter, and we're not using the whatever the X.
That thing that's
not
much. That thing doesn't exist anymore. Yeah.
We're not using that anymore. So we wanted to change some of the wording there. And I was like, okay, we could ask them to re-record it, or let's see if we can do something, with OpenAI. And what was interesting over there is what I thought was that the prompt engineering was very important to get the pronunciation correct, right? Because often,
interesting.
Believe it or not, your last name was difficult. It was not
hard
spelling
for
it.
AI.
It was not announcing correctly. My first name was being a little bit, butchered, I would say. So I had to, kind of almost, coax it into pronouncing it correctly by misspelling the word. I would have to try different variations of the spelling.
Interesting. So you're almost doing a phonetic spelling to get it to. Oh, interesting. I didn't realize that.
I think I had to put like 2 A's to get back to I think something like that. I forget what it is.
Yeah.
But so get all those and I also provided additional context in the prompt to say, this is a podcast about Azure Cloud and all that, and and so it kind of it produced the output in the appropriate tone, right? The professional tone.
Yeah.
It knew the kind of words that I was going to expect. You have to give it some information as to what the topic is about, and then it kind of says it in a nice way, right? So it did eventually come out pretty well. I had to
I
try
think
it,
it sounded great. Yeah, I thought it sounded great.
and they have so many different variations of speaker types and voices and things like that. So it's just a little bit of playing. But yeah, I think I'll put a link to the service that we use in Azure to create it. It's one of our cognitive speech services, I think. But yeah, that was a good, nice, fun exercise.
We need to be careful. We can't advertise this capability too much, or they'll just replace us entirely. Right
That's
at
right.
that point,
Yeah.
have some AI model that's taking all the news, putting some text around it, and then there's the virtual Evan and a virtual Sujit, Kale, Cynthia, Russell.
The virtual podcast.
Yeah.
That's funny.
That's our competition down the road, right? We'll have to up our game.
Yep.
Funny.
Great.
Funny. Awesome. Great. Well, no, it's a great roundup. I appreciate, it's cool to spend, a lot of times we only get to hit a couple of things and not talk about them much. Again, our guests are great to have on, so we obviously want to focus on that, but it's good every once in a while to go do a roundup and just be able to talk a little bit more in depth about this stuff. So thanks for organizing it this week.
Yeah, thanks for making it. And I think we'll have next week a regular guest coming on, right? I think we've got a show next week as well. So
yeah, I think so.
I think so. Get back into the regular rhythm then. All right, Evan. Thanks so much.
Great.
Have a good weekend. Take care.